Section 8.4 is our second type of reaction, which is called a decomposition reaction. In decomposition, we're going to take one compound and it's going to break down into two or more elements or other compounds. Our first example is Mercury Oxide. And so this compound will break apart between the metal and the non-metal, giving me the two elements individually. So I'll have mercury and the oxygen separated from each other. Now all I need to verify is whether or not either one of these is a diatomic. Mercury is not a diatomic, but oxygen is. And so I need to place a 2 next to it to represent that it's a diatomic element. The second example is water. So we're going to have hydrogen and oxygen. Hydrogen and oxygen. Each of these is a diatomic, so they both get a 2 next to them. Remember, as we said in the last section, technically we should balance these equations, and I'll go ahead and put what the ratios are. This one is a 2-to-1 ratio. The second one is a 2-to ratio, 2-to-1 as well. My third example is very special. It is known as the decomposition of a metal carbonate. And you may want to take notes on this. Metal carbonates will always decompose to yield a metal oxide and carbon dioxide. So my metal is calcium. So I'll get as my metal calcium and then oxide, which is O, plus CO2. The calcium oxide, we have to check the charges. Calcium is a +2, oxide is a -2. Those cancel, and so I'm left with the CaO as my answer. To balance this equation, I should end up with, I have 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygens, 1 + 2 makes 3 oxygens. So this equation has a 1-to-1-to-1 ratio. Everything is already balanced. And there's my final answer. The last one is another special one. It's a metal chlorate. Metal chlorates will always decompose to form a metal chloride and oxygen gas. So in this case, the metal is potassium. So my metal is potassium, my chloride is Cl, plus the O2 for oxygen is just O2. I do need to balance the charges in my metal chloride. Potassium is +1, chloride is -1, they cancel. To balance the equation, I'll have a ratio of 2-to-3. In our next section, we'll look at single replacement reactions.